Okay, now we have Ben from Bear cover. Is that still? But it's not their product. But maybe it will be. Yeah, Ben, stage is yours.
Hello, I'm Ben, and this is Johnny. Say hi, Johnny. And today we'll talk about my trials and tribulations of Johnny's sock picking journey. And warning, there's a lot of GIFs in this slide. In these slides, I have a bit of a problem. But before we get to Johnny, let's talk a little about me. So that's me on the left there with my robots. I've had a chaotic and crazy 11-year journey through hobby game development, full-stack web dev. I got obsessed with AI in 2015, which of course led to an interest in machine learning, deep learning, reinforcement learning. And I did my undergraduate thesis in computer vision in 2016 and worked as a data scientist for 2 years in Accenture. And Fernando, Dan, and I, we moved to Berlin in 2020. We were experimenting with lots of different ideas on the left. There was a monstrosity that we built to put some socks into a hamper. And maybe some of you might have seen Fernando's talk a few months ago, where he talked about our nighttime healthcare robots that can see through doors. That's on the bottom right there. And so all of this madness and all these different technologies brought me right here, right now, to this point for Johnny picking up the socks. And I really think that this is the golden age of robotics, but everything is still very, very difficult, and humanoids are also difficult, but I like a challenge, and it's making me a better roboticist. So I've been uploading lots of streams and clips to YouTube. You can subscribe on the top left there. So in November I received Johnny and I was unboxing him. I can't believe I did that video. And then over the time I was then making him go from soccer to sock picking and go to clutter clearing and many other tasks. And kind of losing my mind with complexity. Things got quite complicated quite fast. And humanoids are hard. So like robots are hard in general, but humanoids are even harder, I would say. So if you're interested in more details, check out the channel. So the hardware. I bought them for €900 from Highwonder, a Chinese company. This is actually a pretty good price. Usually these robots can cost €10,000, even for the same size for robot football. He has 24 degrees of freedom, and so that means 24 servos, 2 in the head for pan tilt, 2 in the shoulder, 2 in the elbow, and 1 in the gripper. That's for grabbing things. It's super useful and enables manipulation. He has 2 in the ankle, 1 in the knee for kicking, squatting, and 3 in the hip. And he's powered by a Raspberry Pi 5, but usually I'm using the laptop over the network for neural network. He has an expansion board and voltmeter display. And some other extras is the IMU, 2-hour battery life with a LiPo, and he's kind of this bad rolling shutter camera in the head, which I have to keep replugging and resetting, but it's okay. As for his software, it's all ROS1 noetic. Pretty much all of it is modifiable. The only thing that's not modifiable is this proprietary leg inverse kinematics and gait control, but that doesn't bother me because it just works, and I have bigger fish to fry. I'm working on a more higher level problem. So pretty much I control his yaw angle, how much he's rotating, and also how fast he walks forward. Here you can see an example of this. This is soccer visual servoing, what he comes with. And he's able to track balls with visual servoing. So it means if the ball is to the left, go left. If the ball is close enough, kick. And he has some other applications as well, like tracking faces, following lines, and he can stand up if you fell over. He's a good boy. So you might be wondering by now why socks? Well, I just find it funny. It gives me a chuckle. Life is a bit absurd, and robots are also a little absurd. But also it's a semi-useful loco manipulation challenge. There's a reason we haven't seen robots manipulating in our homes, and the reason is it's hard. You'll see why. And also it's a stepping stone to more complicated tasks, for example, clutter clearing. Here's Roborock on the left. They announced this year. You can actually buy this, and it's bringing, for example, this sock. It's not just me. To the container as a more general version of this task, and you can actually buy this for like 1,400 euros. So manipulation is coming to our homes. The revolution is coming, but like very slowly. And I would say it's useful for parents or kids leaving their toys everywhere. So. And mostly my girlfriend leaves them everywhere. But at least Johnny has a purpose now. So let's actually solve the problem. You do this by compartmentalizing, abstracting, and simplifying the most necessary parts of the problem. So the first thing is, can he actually grasp deformable soft objects? And yes, he can. With a kind of keyframe-based grasp, that means the same joint angles every time. You see where he's grabbing? That's on the right arm, and this is on the left arm. Now that he can grasp, so then I thought we could do the same thing as soccer visual servoing, but instead of kicking, we're going to grasp the sock. So I proved this concept. Remember, I should simplify. First by this red cube on the top left, and on the bottom left you see this manually specified rectangle. And you can choose which to track, and I'm actually tracking this over the network with OpenCV. I also improved the visual state estimation of visual servoing by projecting from the head, given the angles of the head, towards the ground to find a 2D position on the ground. This helps him find the sock better. And now that I've proved that we can pick up things by manually choosing rectangles, the main thing that's left is just choosing, autonomously finding the rectangle. So you can see there's some problems with this. Initially, I thought it was going to be way easier than it actually was. So I first tried Dino V2 foundation model. I also tried Vision Agent from Andrew NG. And yeah, socks are quite a hard object to detect. I think I need more ensembles and maybe 3D perception to get a higher accuracy. So what's kind of learning from this? The real world is hard. Moravec's paradox states that with the things that we thought were hard would be easy, and the easy things hard. For example, we thought coding and chess would be harder than truck driving. We were wrong. So the real world, we make all these plans, and then the real world punches us in the face. And then, as I already mentioned, that the software is quite difficult. So there's lots of architecture and flow diagrams and functional diagrams, and things get quite complicated, lots of abstraction, tens of thousands of lines of code, and things get quite difficult, and every time you add a component there's more sources of error where things can go wrong. So I won't spend too long on the edge cases, but he fails to detect the socks, he fails to track, he uses tracking, he didn't grasp well enough, he fails to realize that he failed to grasp, and standing on the sock that you're picking up. Like how do you deal with that edge case? How many thousands of lines of code do I need to deal with that? Shaky servos, shaky head while walking, and he's fallen so many times, I'm just banging my head against the wall, but here's the result. Socks picked up, Johnny's got it. So after that, after I knew the socks were working somewhat acceptably, I moved on to the harder task of this clutter clearing, and you can see he kind of had a horrible fall here. And just because his arm was then coming down on the container, and then he didn't plan for that, of course. So one way to deal with this kind of edge case is to retreat after you drop the sock into the box. You can see I'm retreating a little. I don't have too much time. I'd love to talk about 3D perception. I love it. But one thing I'll say is that it's actually possible now, even though I only have this rolling shutter camera, with depth estimation. There's loads of foundation models which can get the depth, and from that you can get the point cloud and do plane segmentation. And one way I'm dealing with this complexity is to upscale an architecture, as well as use behavior trees for the full application. Some other cool stuff I'm doing. So there's only one lifetime and so many things to do with humanoids. But on part 4 of the series, I was doing this kind of mic drop application in PyBullet with some kinematics. I'd love to talk to Johnny more. I have some initial things, but I'd love to talk to him more naturally. Slam I've always loved, but I want visual inertial slam. But that's going to be a bit hard again with this rolling shutter camera. And on the bottom left, I'm showing some motion retargeting. So this is taking human poses and then mapping them to robot joint angles. Here's someone doing a jumping jack here, 2 robots, and me doing different movements. And also I've done some reinforcement learning, some very basic version of just trying to make them stand up. And it's always funny to watch this, and you get lots of TensorFlow and plots, loss going down or not. So, but what is the future of Johnny and robotics? There are 3 areas which are making rapid progress. The first is imitation learning. This is actually enabling some things taught decades away to actually do things in the real world for hundreds of different tasks. Another one is foundation models. This takes it even further. So instead of one task, now these models can actually do hundreds of tasks to some accuracy. And it's all one general model that just takes in text and outputs actions. Many different models I'm mentioning here. And also reinforcement learning will scale this even further to get us to 100% accuracy and to do stunts. Here you see Boston Dynamics actually breakdancing better than me. And doing a cartwheel. And after you actually see Helix from Figure, you're able to pick up pretty much any object with this humanoid. So, I could talk for hours about all of this, but everything, in short, and everything before was pretty much classic robotics. You explicitly estimate the state of the world, you plan, you react, you control. Lots of hand engineering. I don't think this is likely to scale to thousands of tasks. Whereas the future of robotics, I would say, is more implicit. We let models themselves decide what is important, what is the next step, what are the correct actions. I think this is the holy grail of robotics, if it actually works. That's left to be seen. Like the hype cycle of humanoids has gone so high now, it might take way longer to get actually tens of thousands of humanoids to be deployed, but progress is happening fast. And I'm actually going to Coral 2025 in Seoul, South Korea, to see this robot learning bubble out, to see how much of it is true. And but this is why I believe we're in the golden age of robotics. There is a path to deal with the complexity of the real world. I'd like to thank Claude 3.7 and 3.5, DeepSeek, 3 not so much, of course Johnny, my girlfriend for dealing with my absurdity and her socks. And my heart goes to all the GIFs that didn't make the cut. On the top right, you can subscribe to the channel. It actually motivates me. It's quite a lot of work. And Bear Cover is hiring. You see on the bottom right, 2 of our robots in the corridor here. And we need a lot of help to scale these robots to 50 plus. We have 5 robots now, and we need to get to 50 and then 50 plus. So we really need a lot of help in ROS and Docker and DevOps. And so reach out if you're interested. Thank you.